corrosion and its prevention. This corrosion is of course in regular normal daily life we frequently come across the concept of rusting of iron. Rusting of iron, where you can see that a metallic iron gets degraded in its quality, will form like a powder, and the metal gets thin, or rather basically it is getting degraded. And also you will see formation of a green layer on the copper metal, aluminum metal, tarnishing of sodium, tarnishing of silver, all these come under what you call corrosion. Rusting of iron, tarnishing of silver, or this is what we call blackening of silver, and formation of inert oxide layer on aluminum, copper, basic copper carbonate. All these will come under this concept called corrosion. Why we are studying this corrosion under electrochemistry? Because the basic principle involved in the corrosion is redox reaction. So based on that redox reaction also it works like a galvanic cell. That is the reason what we are studying under electrochemistry. This corrosion in fact is a very huge topic, and it is in fact a one special branch in engineering studies. But here we have only a brief discussion about this corrosion. So basically what is a corrosion? Corrosion is nothing but degradation in the quality of metal. Why there will be a degradation? Because what happens is metal gets oxidized to stable metal oxide. Metal gets oxidized to stable metal oxide. That is what actually happened. So basically what happens, iron gets oxidized to ferric oxide, silver gets oxidized to silver oxide, aluminum gets oxidized to aluminum oxide, copper gets oxidized to cupric oxide. So what is happening? Basically here what is happening is metal converting or going back to stable ore form. Actually we extract metal from ore. So why metal actually will exist as in the combined state? Because that oxide or sulphide or carbonate or bicarbonate, whatever that we have in the ore, that is actually more stable rather than the metal. So most of the metals will exist in the combined state as oxides or sulphides or carbonate ores. Now what you are doing, you are extracting a metal. In the metallurgy what we do, from the different ores we extract the different metals. Once the metal is extracted, that we use it for different purpose. But metal is not stable. So whenever that metal comes in contact with any oxidizing substances like oxygen gas, especially along with water, moisture, or in acidic medium or basic medium, the cell reaction propagates and you will get more what you call, again the metal converts back into its stable form or ore form, that is metal oxides. Especially in the rusting of iron, if you see, what happens is iron gets oxidized to Fe2 plus. This is anodic reaction, and this oxidation takes place when oxygen gas come in contact with the iron metal, especially in acidic medium or even basic medium or even with water. So as a result what happens, what you will get is water. So overall reaction is that 2Fe plus O2 plus 4H plus. So when iron metal comes in contact with oxygen gas in acidic medium, this converts to what do you call Fe2 plus, and this Fe2 plus, so here what you are getting is FeO. This FeO or Fe2 plus further reacts to give Fe2O3, and the Fe2O3 with water changes to hydrated ferric oxide. Finally, this is what is called rust. The formation of hydrated ferric oxide is what is called rust. So, iron metal converted to hydrated ferric oxide, that is powdered. So, very high quality iron metal when come in contact with oxygen gas, atmospheric oxygen in acidic medium, finally converting to powdered rust, that is hydrated ferric oxide. This whole sequence is what is called rusting of iron. So, here this reaction is taking place like a normal oxidation reaction at anode, and this reaction is like a reaction that is taking place at a cathode. So, this part where this oxidation takes place acts as anode, and the electron, as it keep moving away, it will spread over to the whole metal, and the whole metal gets corroded, that is cathode. So, sequentially anode, cathode and are placed in the whole metal, and finally the whole metal gets rusted up. Then how to prevent this rusting? To prevent this rusting, we have different techniques. To prevent this corrosion, to prevent this rusting, we have different types of solutions for this. What are they? It is first painting. When iron sheet, iron metal gets painted up, then formation of having that unreactive layer of paint will prevent iron to get oxidized easily, because having a layer of paint on the surface of a metal prevent the iron metal to come direct in contact with the oxygen atmospheric gases. So, we can prevent the corrosion, point number 1. Point number 2, add, this is what we call sacrificial anode to the metal iron. Just if you attach a zinc plate, as the zinc is more reactive than iron, zinc will undergo preferential oxidation rather than iron when atmospheric gases comes in contact. This is what we call galvanization. Another very important term, galvanization. Galvanization is a process of connecting the iron substance to a zinc metal, whereby preventing the corrosion. This is galvanization. So, in the galvanization, zinc is coated. Here in the galvanization, what is done? Zinc coated on iron surface. Right. Zinc is coated on iron surface. As a zinc coated on iron surface, zinc undergoes preferential oxidation and prevents corrosion or rusting of iron. And this even you can see on the boat, when ships, at the bottom of the ship, magnesium bricks are allowed to place, so that what happens is, when ship base comes in contact with the water, it is not the iron, but it is the magnesium which is more reactive with oxygen, will undergo preferential oxidation and will prevent the rusting of iron on the ship or corrosion. So, like this, first having painting, taking an inert layer, sacrificial galvanization, sacrificial anode, these are the various methods by which we can preventive methods for corrosion. Here even the cell reactions, the EMF is also, as we know, for this the EMF is minus 0.44, for this EMF is plus 1.23, overall for the cell reaction the EMF is 1.67 volts. So, high EMF. So, what it indicates is that as the cell potential is highly positive, this is a very spontaneous reaction, delta G will be very highly negative. So, this basically the purpose is that how spontaneous the corrosion of iron is, rusting of iron is. Rusting of iron is a spontaneous reaction. It is a spontaneous, as in when it comes in contact with oxygen, it takes place. So, to prevent this, we use any of the techniques called the cover the metal surface with the layers like paints, varnishes, or go for galvanization, where zinc is coated on the iron metal, or metal wires like magnesium wire or magnesium metal lining can be made on the surface. And also another thing is, as far as possible, try to avoid bendings, screw fittings, joining, welding, as far as possible to avoid while designing any particular instrument or device. Because if you have a bent one iron rod and another iron rod, if they are like if they are kept like this, then at the bend there is a scope for water to get stagnated, and that stagnated water, oxygen will dissolve in that. That dissolved oxygen will undergo reduction. That reduction will allow more iron to oxidize. Similarly, when there is a screw fitting, when screw fitting is there, between the screw and the metal surface, in between, water gets stagnated. When the water gets stagnated, again oxygen dissolves. So, what basically I mean to say is, a plain surface of iron and rough surface of iron, or bending surface of iron, screw fitted surface of iron, nut fitted surface of iron, if you compare, plain surface of iron is least with respect to rusting. That will not undergo rusting easily, rather than if you have bendings, if you have joints, if you have weldings, if you have screw fittings, if you have nut fittings. So, to prevent the corrosion, not only these methods, but preventive measures, what we have to take is, as far as possible, one has to keep the surface of iron as plain, as smooth as possible, so that even if it comes in contact with water, water cannot stay and it flows from it, and we can reduce the chances of getting corrosion. One cannot prevent, but one can reduce the chances. But if any of these methods are followed, even we can prevent the rusting also.